Hello, hi everyone, good afternoon. So welcome back again. We are going to start with velocity time graph. In the last class, we have learned about distance time graph. So today's topic is velocity time graph. So let's begin. So this is about me. If anyone here is new and seeing me for the first time, so let's quickly revise what we did in earlier classes. So there is a formula for average velocity. So what is average velocity? It is the displacement divided by time. And what is acceleration? It is change in the velocity divided by time. Hi Srishti, Devanshi, Gaming Wenzi. Hi, good evening everyone. Yeah, so these are the two formula that we have learned in the earlier classes. So we are going to use them and we are going to learn about velocity time graph. I hope you have understood the distance time graph, and I had given you one homework in the last class. Did you solve? Hello Satvik, Raj. Did you solve the question? This was the homework I had given you 2 days back. The question is, what is the speed of the object during the first 4 seconds of the journey? So these are the first 4 seconds. So within this time, what is the speed of the object? Hi Laughter Club, Devanshi, you have solved, nice, awesome. So how will you find the speed? So speed in the, there is a distance versus time graph. So in the distance time graph, speed is nothing but the slope of the curve. C is the correct? Awesome Devanshi, nice. Yes, in the distance time graph, what is the speed is nothing but the slope. And how will you find the slope of this graph? So slope is nothing but the rise, there is a rise divided by run. So what is the speed? Speed is nothing but the slope, which is the change in the y-axis, which is our rise. Okay, I'll write down rise divided by run. So what is the rise? It is change in the y coordinate divided by change in the x coordinate. So how the y coordinate has changed? From 0 it has came to 75. So this is 75 minus 0. And what is the change in the x coordinate? It is 4 minus 0. So this is 4 minus 0. And what is the unit? This is in meters, it is in seconds. So this would be in meter per second. So the speed is equal to 75 divided by 4, which is 18.75 meters per second. So that is the correct option, option number C. Okay, Jagga, Sandhu, good evening. Alright, so now let's learn about velocity time graph. So again, we have the two variables. There is a velocity and time. So which one will you plot on the y-axis? If you want to choose, I told you the reason, time is always going to be independent. Time is always the independent variable. So time will come on the x-axis and the velocity will be on the y-axis. Because time is independent, velocity will depend on the time. Correct? So that is the reason time is taken along the x-axis, it is independent variable. Velocity on the y-axis is a dependent variable. So this is why it is called as velocity time graph. Correct? Now, let's understand different types of the graph. So first one, the graph is a straight line parallel to time axis. There is a graph which is parallel to our time axis. There is a velocity time graph. So what is the meaning of this graph? Is the object at rest? Can you tell me? Is the object at rest? Is this object at rest? Because whenever I show this graph, velocity versus time graph, which is parallel to x-axis, almost 50% of the students, they say the object is at rest, but that is not true. It is not at rest. Velocity is 0? No, Devanshi. See, I told you 50% of the student, they make this mistake. This object is not at rest. It is moving with this velocity. Let's suppose the unit here is meter per second. This time is in second. So the object is moving with 40 meter per second. That is a constant speed. So what is the speed here? This is a constant speed. Constant speed is nothing but our uniform motion or uniform velocity. So whenever the object is in uniform motion, the graph will look something like this, which is parallel to our time axis, moving with a constant speed. Nice maths. Correct. Now let's understand few more different types of graph. Let's suppose, okay, before that, let's understand how can we calculate the displacement from this velocity time graph. There is a velocity, there is a time. So if you want to calculate the displacement or find out the displacement is nothing but the area under this curve. So this figure, what is this? OABC. This is a trapezium. So the displacement is nothing but area under this curve, right? So what is the displacement? Area under velocity time graph. That is this area of the trapezium OABC. So how will you find the area of a trapezium? Do you know the formula? The formula is half into sum of the parallel sides multiplied by height. So which are the parallel sides? This OA is parallel to this BC. So I'll write down OA is parallel to this side BC. So sum of the parallel sides. And what is the height? Height is the shortest distance, or okay, I'll remove everything. So what is the height? Height is nothing but this length of this graph, that is the height. Height should, so the segment which is making 90-degree angle with the parallel sides, that is called as height. So these are the two parallel sides, OA and BC, these are parallel sides. So sum of the parallel side, it is this multiplied by OC. So what is this OC? It is the height. So this is how you find out the displacement from the velocity time graph. Is it clear? Clear? Now, yeah, this is how it is. So this is again a velocity time graph. Now you see this object is going up, coming down, going up, coming down, and it is plot here. How it is this height? So how the height of a trapezium is defined? So whenever you have a trapezium, so trapezium can have different shapes. Let's suppose the trapezium is something like this. These are the parallel sides, correct? This is one kind of trapezium. Yes. So in that trapezium, this is the height. Height is the segment which makes 90-degree angle with the parallel sides. Now, if these are the parallel sides, these are, let's suppose, parallel sides, something like this. So the side which makes 90-degree angle, so this is the segment, this segment, it makes a 90-degree angle with the parallel sides, that is called as height, correct? So now this line OC, it makes a 90-degree angle with these parallel sides. So that is why it is called as height of this trapezium. Okay? Problem, will go to the problems, we'll solve some questions. Before that, I want to show you this graph. So now this object is going up, coming down. Object is going in the upward direction, then coming back in the downward direction. So this is a velocity versus time graph. So how it is looks like? At the beginning, when the object is going up, it has a maximum speed in the upward direction. So let's choose. So we can choose. Do you remember Cartesian sign convention? So upward is positive. and something is going down, that is negative. Okay, you remember Cartesian rules, whenever the object is going up, that is called as positive direction, going down, which is a negative direction. So now here, when the object is going up, you start your stopwatch. Okay, so at the initial speed, let's suppose whatever is the initial speed here, that is a positive value. So as the object reaches to the maximum value, so when the object reaches to this point, what happens? The velocity becomes 0. So it is somewhere here, this point here, where the velocity is 0. So when the object reaches to the maximum point, velocity is 0. Now objects start going down. When the objects start going down, what happens? The velocity will increase in the negative direction. So it starts at 0 and keep on increasing in the negative direction. Correct? So this is how the velocity time graph will look like when the object is moving in the vertical direction. So there is again a straight line. Let's understand few more properties about this type of curve. Any questions until now? Any questions? Any doubts? Okay, so now whenever you have a straight line in the velocity time graph, for example, there is a straight line. Can you see? There is a straight line. There is a velocity versus time graph, and you have a straight line. So for the straight line, you can find out the slope. Can you find out the slope? Slope is nothing but, what is the slope? Let's suppose you choose two different points. You choose these two different points. So what is the slope? Change in the y coordinate, that is change in the y coordinate divided by change in the x coordinate. Okay, so what is change in the y coordinate? Let's suppose this is our initial velocity u, this is the final velocity v. So change in the y coordinate is nothing but v minus u. Okay, this is the change in the y coordinate, or change in the velocity. What is the change in the x coordinate? It is final time, so t final minus t initial. So change in the x coordinate is nothing but t final minus t initial. There is a change in the time coordinate. So what is the slope? So here in this case, the slope is nothing but change in the y coordinate, delta y divided by delta x. Delta is this triangle is called as delta. It is a Greek letter. It means change. We use lot of Greek letters in physics. So this is a Greek letter called as delta. Okay. So this is change in the y is v minus u divided by t final minus t initial. There is a final time minus initial time. So you can, if you start your stopwatch at this point, so you can assume that t initial is 0. So t final becomes the total time duration. So this is simply time. So do you remember this? V minus u divided by time. This is nothing but our acceleration. So whenever you have a straight line in the velocity time graph, if you calculate the slope, that slope is nothing but our acceleration. Clear? So there is an accelerated motion of a body. So whenever you call it as an acceleration, if there is a change in the speed or change in the direction, because do you remember acceleration is a vector quantity, even the velocity are vector quantities. So in the vector form, we can write the acceleration vector as v minus u divided by time. So whenever there is a change in the direction, then these initial velocity and final velocity, they are not going to be equal, they are going to be different. For example, if the object was moving in this direction, there is an initial velocity. Now it changed the direction, there is a final velocity. This initial velocity and final velocity, they are different. So even in that case, there will be a acceleration. And there can be change in the both speed and the direction of the motion, correct? So here when we calculate the acceleration, it is the only the value of the acceleration or the magnitude of the acceleration. In the graph we cannot get, that is a, like I would say, disadvantage of the graph. You cannot tell the direction. So here the variable which is the direction, that is missing. So from the graph you can calculate the magnitude of the acceleration, not the direction. Okay, is it clear until now? Great. So now let's understand few more types of graph. So this is a velocity versus time graph which is parallel to our time axis. Whenever you have a velocity versus time graph parallel to time axis, that means there is a constant speed. Constant speed. If there is a constant speed, what is the slope? So for this graph, slope is 0. There is no change in the initial and final velocity. If let's say if I take 2 points here, there is the initial velocity and final velocity. So initial and final velocity, they are 0. They are equal. So the difference in the initial and final velocity, that is 0. Okay. So what is the acceleration? Acceleration is v minus u divided by t, but u is equal to v. In this case u is equal to v. So the acceleration here is 0. So for the uniform motion or motion with a constant speed, acceleration is going to be 0. Clear? Yes, Devanand, what is your question? Now another graph, there is a uniform acceleration. So what does it tell you here? Whenever you get a straight line in the velocity time graph, whenever you have a straight line, straight graph, that means again you can choose any 2, 3, any number of points, and what you will find out that the slope, there is a straight line, so the slope of the straight line is constant. So here slope is constant. If the slope is constant, just now in the previous slide I told you the slope in the velocity time graph is our acceleration. So in this case acceleration is constant. So there is an example of uniform acceleration or constant acceleration. One doubt? Yes, what is your doubt? New thoughts? Just type your doubt, I'll answer. So now these are the two different types of graph. They are not straight line. Can you see? This is not a straight line. So whenever you get a curve in the velocity time graph, these are all curved lines. This is also curved line. So whenever you have a curved line, these are non-uniform acceleration. Straight line, then uniform acceleration. Curved line, non-uniform acceleration. Clear? Now let's solve this question. Okay, here you can find out, like sometimes if it is non-uniform acceleration, from the graph you can guess if the acceleration is increasing or decreasing. How will you guess that? Let's suppose if I choose one point here, there is a tangent. If I choose another point here, there is a tangent. So what is happening? The slope is increasing. Slope is increasing, or this tangent is becoming more steeper. If the tangent is becoming more steeper, you can say it is a acceleration is increasing. Acceleration is increasing in this case. Okay, how about here? Here, let's suppose you take different points, point number 1, point number 2, point number 3. So this is these are the tangents. So what is happening? In the first case, like in the first region, let's suppose first half from A to B. From A to B, what is happening? What is happening? The curve, the straight line, that is a tangent. the slope of the tangent is, the magnitude of the slope is increasing. Earlier tangent is not that steeper, but at point B tangent become more steeper. So the magnitude of acceleration is increasing. So the magnitude of acceleration, I am writing in this way, it is increasing from A to B. Okay, and from B to C, what is happening? The steepness of this tangent is decreasing. So from B to C, what is happening? The magnitude of the acceleration is decreasing in this graph. At B, the tangent is steeper. At C, it is becoming like flat. So the magnitude of acceleration is decreasing. Clear? If you have doubts, any questions, just type the doubts. I am looking at your chat. If I see the doubt, I will just explain you that. Okay? Now solve this question. So the question is, there is a velocity versus time graph. Velocity time graph. So what can you infer from this graph? Option A is correct. Nice, Raj and Devanshi, correct. So this is an example of a uniform motion. That is correct. You see here, the velocity is constant. The velocity is not changing at all the points. Let's suppose there is a V0. At all the points, velocity is V0. So this velocity is not changing with time. If the velocity does not change, it is a uniform motion. This is not at rest. Most of you like confuse that, you think this is a distance time graph and you will say this is a at rest. That is not correct. Okay, this is not a non-uniform motion. So let's go to the nice Simran, Sneha, Devanshi and Raj. Awesome, all correct. Great. Solve this. So area under the velocity time graph represent a physical quantity which has a unit of. So which unit it has? If you have the velocity versus time graph, let's suppose there is a curve. Let's suppose there is a curve and you find out the area under the curve. You find out the area under this curve. So what is the unit of this? Meter per second? No. A is meter square? No. What is the area under this curve? When you find out the area, so area is nothing but displacement. When you calculate the area under the velocity time graph, you will get the displacement. So what is the SI unit of displacement? It is meters. That is the correct option. Option number B. It is not meter square or meter cube or meter per second. Okay, clear? Easy, right? Let's go to the next question. So I'll explain the question first. This graph shows position as a function of time. There is a position and this is a time. For a moving object along a straight line, during which times or time the object is at rest. So looking at this graph, you want to tell me when the object is at rest. Remember, there is a position, that is our distance or position of the object. This is not the velocity, there is a position. Answer C is correct. Okay. All right. So when you can see the object is at rest, object at rest means the position of the object does not change with time. You see here, from this position to this position, the position of the object is fixed. Object is not moving from t is equal to 1 second to t is equal to 2 seconds. So in this duration, object is at rest. So that is option number B. Clear? Nice. Dunk noob. Veer Singh, correct. Raj, Devanshi, congrats. Now let's understand, there are 3 equations of motion. Let's do a quick derivation of 3 equations of motion using our velocity time graph. Okay, this is a velocity time graph. So you remember the acceleration. How will you calculate the acceleration? Acceleration is nothing but the slope of this graph. So I'll explain you what is this graph about. This is a point A, there is a velocity, there is an initial velocity u. So yeah, there is an initial velocity u and there is a final velocity v. So this length OE or BC, that is our final velocity, and the initial length, that is AO or DC, that is u, correct? Now this is our time, there is a time axis. So initial velocity is OA, AO, which is u, final velocity is BC, there is the final velocity which is v. So this difference BD, so what is this difference? It is simply BC minus DC, BC minus DC, which is v minus u. So this length is here, this length from here to here, there is v minus u. Okay, and what is this length? Which is, so there is a right angle triangle, right angled, there is a rectangle, there is a rectangle. So the opposite side, they are equal. If this is a time axis OC, so there is a time t, so this should also be time t. AD is our time t, correct? And there is a CD and AO, they are equal, that is our initial velocity u. So now how will you find the acceleration? Acceleration is simply the slope of this graph. Slope is nothing but change in the y coordinate, which is BD divided by AD. What is BD? V minus u. What is AD? It is time. So you get this equation, and from this, if you rearrange the terms, you get this equation. Just multiply both sides by time. So you get AT is equal to V minus u. So take the u to other side, you get this equation. So this is called as first equation of motion. V is equal to u plus AT. It gives the relationship between velocity and time. Okay, this is the first equation of motion. Now let's go to the second equation. Here again the same graph. You see the same graph I am using here. Now I told you in the velocity time graph, the area under the curve, if you find out the area here, this area, so area under the curve is nothing but the displacement. You remember? So there is a trapezium. So area under the curve is the displacement, which is area of this trapezium OABC. Now you can divide this trapezium. There is a trapezium, you can divide it into this triangle and the rectangle. So area of the trapezium is nothing but area of this rectangle OADC plus area of this triangle. So what is area of this rectangle? Area of the rectangle is nothing but base into height. Base is base is OC multiplied by height, which is OA. There is a height into base. And area of this right angle triangle is nothing but half multiplied by base is AD multiplied by BD. So half AD multiplied by BD. Now just substitute the values. We remember the values in the last curve. So this OA, which is the OA, this one, which is our initial velocity, that is this u. What is OC? OC is this, which is the time. So that is time, ut. So you get the first term. Now half of AD, what is AD? It is this length, which is the time, there is a time, there is a AD. And what is BD? BD is nothing but V minus U. So it is from the earlier graph. Do you remember what is V minus U from here? So from here V minus U is nothing but AT. So I can write this V minus U is nothing but our A times T. So substitute those values here. So you will get this equation, S is equal to UT plus 1 by 2 T into AT, and simplify, you will get this equation. This is called as second equation of motion. So it gives you a relationship between displacement and time. The relationship between displacement and time. Okay. What does AOCD describe? AOCD is this curve. You see here, this A, O, C, B, AOCD. Okay, there is a mistake. It should be, no, it is correct now. OADC. It is OADC. It is this rectangle. OADC is this rectangle. This is a rectangle. And there is a right angle triangle. So there is a triangle. Okay, this ABD, it is a right angle triangle, and this one is the rectangle. So area under the curve, you can either take the area of a trapezium or you can divide. This is a rectangle and this is the triangle. So this is how you get the second equation of motion. Clear? And now let's get the third equation. Again the same figure and same strategy. So again the distance or the displacement is nothing but area under this curve OABC, which is our trapezium. So now how will you find the area of a trapezium? It is nothing but these are the parallel sides. These two are the parallel sides. So half into sum of the parallel sides multiplied by height. So what is this height? Height is this length. This is the height. So I told you why this is the height, because it is making an angle 90 degree to both parallel sides. So in the trapezium, if these two are the parallel sides and height is nothing but this is the height. These two are, let's suppose we call it as line number 1, line number 2. These are the parallel sides. How will you find the height? Height is nothing but a segment which is making an angle 90 degree with the parallel sides. So it is this length OC. So that is our height. Clear? So now substitute the values. What is OA? OA is this length which is initial velocity U. What is CB or BC? It is V. So U plus V multiplied by time. But now do you remember the first equation? First equation it says V is equal to U plus AT. Now you take the U to other side. So V minus U is equal to AT. So from here time T is equal to V minus U divided by acceleration. So use this formula for time, substitute it in this equation. So it is simply, yes, time is this value because of the first equation of motion. Substitute it in the earlier equation, you will get V plus U, V minus U divided by A, and here is 2. So rearrange the terms. So this 2A multiplied to the both sides, so you will get 2 times AS. And what is this? V plus U, V minus U? It is simply V square minus U square. In algebra you must have learned this. A plus B, A minus B, which is A square minus B square. So something similar. So that is our third equation of motion. So remember all the three equations. The first equation, this V is equal to U plus AT. This is a velocity time relationship. Then the second equation, S is equal to UT plus half AT square. There is a displacement time relationship. And the third equation, v square. So we had this equation. You can rearrange this. You can rearrange this as v square. Take this u square to the other side. So this will be equal to u square plus 2as. This was negative u square. If you come, you take it to the other side, it will become positive, right? So that will be your third equation of motion. And what is this? There is a velocity and displacement relationship. Velocity, displacement relationship. So these are the three equations of motion, and there are a lot of questions based on these equations. The derivation is not that important, but application, how to use this equation, that is super important, and we'll solve the questions in the next class. What is the use? Because let's suppose you're moving on a road, and let's suppose there is a wall in front of you. You want to stop. If you know the distance between your car and the wall, you need to apply the brakes, correct? So if you can apply the brakes, then only you won't collide to the wall. So how can you know how much force you need to apply? So you can use these equations and you can find out what is the acceleration and from what is the force. So that is why in real life there is a lot of application of these equations. These three equations, they are called as kinematics. So there is a branch of physics which deals with motion of the object, and mostly it is these three equations we are going to use. Okay, so there are a lot of applications, and if you are in grade 9 in your school exams, lot of 4 mark 5 mark questions will come from these three equations, not the derivation but the application in real life examples. Okay, so we'll solve those questions in the next class. So that's it for today. Thank you so much everyone. Do follow this link, you'll get the notes in this Telegram channel. Bye bye everyone. Maha Krishi, welcome. Bimla, bye, take care.